Chapter 3 deals with transformations, with 3a, b and c dealing specifically with the different transformations that we do have. So 3a is translations. Previously we've looked at translations with the form of this, so f of x minus h plus k, where h and k are our translations horizontally and vertically. So moving along the x-axis is our h value and the k is moving up and down. Now previously when we've done this, we've recognized that this negative in front of the h, we can make this x minus h equal to 0 and solve for x to get our horizontal translation of positive h. The method that we're going to use over the coming lessons is actually looking at the coordinate points and the shifts with respect to those points. This method's really good because it will allow us to calculate the transformations for equations that are not in a nice format like this one here. So let's just look at what the first thing here that we're looking at is if you've got a positive shift, then it's taking your coordinate points of x and y and adding a value. So it's taking the x value, let's say -1, and moving it across 2 units, so plussing 2 to get to 1. So it's a positive shift in this coordinate for this coordinate point. The y value is also shifted positively, so that's going to go up, and then this is just going to give us our new x and new y. So x dash y dash is the new x and y. The negative is exactly the same, but we're just moving backwards. So x minus h and y minus k are implying a negative shift in the x-axis and a negative shift in the y-axis to give a new x and a new y. These shifts are parallel to the x-axis and they don't change the shape. It's just shifting the graph. So looking at each of these separately, we get these 4 situations here. So the first one is a positive shift in the x-axis, which means that we're going across positive direction in the x-axis. Our coordinate point is a plus, and actually when we substitute and rearrange, that turns out to be a negative in our equation, so x minus 1. If we go for a negative shift in the x-axis, we're moving to the left with an x minus 1, and again we change that sign and we get a positive 1. A vertical shift in the positive direction is moving up, and we just tack on a plus 1 on the end. Negative moving down, minus 1. The main method that we're going to focus on is this algebraic method, where we look at the coordinate points. So for instance, you can have a shift or a translation of 2 units right and 4 units up. That will take your coordinate point, where x is the pre-image and y is the image. So the x plus 2 is at 2 units right, and y plus 4 is 4 units up. So the image is y plus 4 and the pre-image is x plus 2. This is your new x and your new y. So your new x value is x plus 2 and your new y is y plus 4. In your original function, you had y and x, not new y and new x. So what we're going to do is rearrange these 2 equations to get x and y by themselves. This becomes x new minus 2 and y new minus 4. If we do a straight substitution where y is y new minus 4 and x is x new minus 2, you can then get an equation which looks like this. So the function y equals x squared maps to y new minus 4 is equal to x new minus 2 squared. This and this being put in here. If we rearrange that, because we never want y with anything else, we get y is equal to x minus 2 all squared plus 4. That is the equation or the function where we've translated y equals x squared 2 units right and 4 units up. This method will work, and we're going to follow through with this method a lot. Alright, example 1 asks us to find the equation of the image, i.e. like the y portion of the function, of the curve with the equation y equals f of x, where f of x is 1 on x, under a translation of 3 units in the positive direction of the x-axis, so 3 units positive or to the right, and 2 units in the negative direction, so 2 units down. The first step for this is to write a notation for the translated points. So we're going to take a coordinate point of xy, and we're going to change this based on our translations. So our translation 3 units positive direction of the x-axis is taking the x portion of our equation, the pre-image, and positive direction plusing 3, so x plus 3. The y portion, 2 units, negative direction, y-axis. So our y coordinate point, and we're going to move it minus 2 points. This is our new x and our new y. We can then take this and make an equation. So we know that given that this part here, x new, is equivalent to this part here, x plus 3, we can write this as x new is equal to x plus 3, where if we rearrange, x is going to give us x new minus 3. I can do the same thing for the image portions. So y minus 2 is y new, so y new equals y minus 2. Rearranging this, I can get y is equal to y new plus 2. So if I want my new function, i.e. the function that's undergone the translations, then I can take this value of x and this value of y and substitute it in for the x here and the y here. The first thing to do though is to rewrite this equation here as one thing. So instead of f of x, I'm going to write 1 on. So y is equal to f of x, which is equal to 1 on x. Substituting in for y and for x, the new values that we just found. It's a straight substitution. So where I have y, I'm going to write y new plus 2, i.e. this here. And where I had x, I'm going to write x new minus 3. So x new minus 3. We don't leave an equation like that, so just rearranging it, we get y new is equal to 1 divided by x new minus 3, and then minus 2. So by old format, when we were doing equations, we could read off this a shift 2 units down, which is awesome, so 2 units in the negative direction, and switching the sign in the middle, plus 3, so right 3 units, which is what we're after here. It seems like a lot of work for a pretty simple equation, which previously we've done by, I suppose, hand or just recognition. But with more complex equations, this process of finding the coordinate points and shifting the coordinate points and then rearranging and substituting is actually a very easy and almost a mistake-proof method, which is really important.